Hi Precalculus, I'm Mrs. Leopold. If you were away at IASTIS this weekend, I hope you had a great time. I hope you feel good about what you accomplished, and hopefully now you're ready to focus on your academics again. So I'm going to take you briefly through lesson 6. I'm not going to explain every single problem to you. I'm just going to talk you through a few things to help you get on the right foot, and then if you have follow-up questions, you need to go see your teacher. So on this first page, we show you 6 different graphs, and down here, if you look at example 1, it says identify the asymptotes for each function above. So we've already studied some of these. You're familiar with this exponential growth, exponential decay, what that looks like, where the asymptote is, right? We have a horizontal asymptote at y equals 0. Growth increases as x increases. Decay, you have a negative exponent, or it can be 1 over. It decreases as x increases, still a horizontal asymptote of 0. Down here, you've done natural logarithm and common logarithm, right? And so if you have a logarithm, you have a vertical asymptote instead at x equals 0, and then it increases as x increases. Same thing here, vertical asymptote of x equals 0. So the 2 new ones are this Gaussian model and the logistic growth. And the one we're really going to focus on here in our word problems here at the end is the logistic growth function. So you can see we have 2 asymptotes and a logistic growth function. We have a horizontal asymptote. Depending on what this formula is here, you're going to have 2 different horizontal asymptotes. One of them is going to be at y equals 0, but we'll talk about this more when we do the example. This won't be significant because the y equals 0 happens when you have a negative x value, and in most cases, based on the scenario, you're not going to use the negative x values. But again, we'll talk a little bit more about it when we do the problems later. Okay, example 2. So I'm going to take you through the answer key that's already provided. I'm just going to talk you through the problems. Example 2, it says find the domain of the function f of x equals 1 minus 3 ln of 2x plus 5, and hence identify the equation of the asymptote. There are 2 different ways you could do this question. One is to say to yourself, hey, I can never have a negative number right here next to my ln because I have a positive base of e, and a positive base of e raised to a power is always going to produce a positive answer. So I'm going to take 2x plus 5 and put that greater than 0 to make sure it's always positive, and then I can solve, and this is my domain. But not only is it my domain, it also establishes then what my vertical asymptote is. So my vertical asymptote has to be at that value, and then everything greater than that, so everything to the right of negative 5/2. So my vertical asymptote is just x equals negative 5/2. Option number 2 for solving that problem is to factor out, right, that horizontal dilation. You factor out the 2, and then you have left x plus 5/2, and then of course if you set that equal to 0, you would find what your vertical asymptote is. So it's again everything to the right of negative 5/2 for the domain. It's not asking for the domain, it's just asking for your vertical asymptote. So that's it on page 1. Okay, example 3. I'm only going to take you through example 3, part A and part B, and then you should do example 4 on your own, then check the notes answer key online to see how you did. So example 3 should be pretty intuitive. You should instinctually know what to do here. We give you 2 points, the point 2, 1.12, and 5.07168. are on the graph of an exponential function. We're asking you to get the equation of this exponential function. So obviously you have your x coordinate, your y coordinate, your x coordinate, your y coordinate. So you just substitute in to your x and your y value. So it's going to be, my y value is 1.12, so 1.12 equals a times b to the x value. And then isolate and solve for a. We substitute in the other y value of 0.07168 and the other y value of 5, and again isolate a. So why do we do that? Because we have a system of equations, we can set them equal to each other because they both equal a. So I set up a proportion where 1.12 over b squared equals 0.07168 over b to the fifth. I cross multiply to get 1.12 b to the fifth equals 0.07168 b squared. I divide each side to isolate my b, so I get b cubed equals 0.064, and when I take the cube root of both sides, I would get an answer of 0.04. When I plug that back in to find my a value, because remember, what are we trying to do here? We're trying to find our a value and we're trying to find our b value. So when I plug it back in, I have my b, I substitute that in. Now I have to find my a value. So I plug it into my original function, or use a point. Sorry, I'm one of those original points. Plug it into your function to get your a value. And now we have our a and our b. So sorry, I hope that made sense there at the end. And there we have it. So my final equation is 7 times 0.4 to the power of x. Now, the second one, part B, is instead of getting the equation or the function in the form of a times b to the x, we're going to get the function in the form of p times e to the RT power. So it says we could also write this equation in this form. So how would we do that? Well, your t is your x value, right? And your f of t is your y value. And if you weren't sure about that, or you wonder why we knew that, well, because it says f of t. But your time is your x value in this case. So we have 1.12 equals p times e to the RT. So we put the 2 in for t. We do the exact same thing, a system of equations, isolate p, set the p's equal to each other, right? So you might want to pause, do this on your own. We cross multiply, we then divide, e to the 3r equals 0.064. So we take the ln of both sides. That 3r goes in front, ln e equals 1. So we get 3r equals ln of 0.064. Divide each side by 3. Well, dividing by 3 is the same as multiplying by 1/3, and you put it in front, which means we can raise that to the 1/3 power. And what is 0.064 to the 1/3 power? It's ln, or that, sorry, it's 0.4. So r equals ln of 0.4. So if we plug that in, we plug it in, we would still get a value of 7, right? So it's your initial amount. That's the same as your letter A up here, your initial amount. But look at this. Instead of getting your B, what is your B equivalent to? Well, you can see that e to the power of ln 0.4 is the same as 0.4. Those are the same, representing the same value there. And why is that? Well, remember this e to the power of ln e 0.4, these are the same, so my answer is just 0.4 because those cancel each other out, and I have just 0.4. So B, if we were looking at the substitution method, this B up here is the same as e to the power of the rate, right? E to the power of r. These are the same thing. They equal each other. Again, if that doesn't make sense, you can talk to one of your teachers about it. It's kind of hard to explain that on the video, but talk to one of your teachers about it, see what you, or just try to stop and process that and really look at it again. You can see if you understand it by doing the example below, but again, I'm not going to take you through that. So go through the example below, see if you can figure out what's happening, and then talk to your teacher if you're still confused. All right, page 3. Okay, so the last problem I'm going to explain is this word problem. So it's about a logistics function, right? So that's the type of word problem we're going to do. This is the type of graph you're going to have when you plug it into your calculator. So what is the logistics function? Well, it's, again, when you have rapid growth at the beginning, but then the growth eventually tapers off. So you might have rapid growth at the beginning, it tapers off, and it doesn't grow as fast. And an example of why that might happen is the spread of disease. So if you have a limited population somewhere, like we do on the island of Singapore, then you're going to have the spread of disease be limited after so much time. So the spread of disease might be really, really fast, and then suddenly it tapers off, only if people aren't leaving the island, coming back, different people coming back, right? But eventually, if you only have a certain population on the island, it's going to reach that maximum population, and then no one else can get the disease because everyone has it. So that's what a logistics function will look like. It'll start to taper off at the high end. The formula for a logistics function is P of x equals a divided by 1 plus b times e to the negative rx, where P of x is the population and x is the time. So that is going to represent population growth. So here's an example below. On the SAS campus of about 4,500 people, a student returns from interim with a contagious, long-lasting virus. The spread of the virus can be modeled by the function f of t equals 4,500 divided by 1 plus 4,499 times e to the negative 0.8t, where f of t is your number of people, number of students infected, and then t is the number of days that have passed. We know that SAS is going to cancel classes when 40% or more of the people are infected. So part A. It says find f of 5 and explain what this means in the context of the problem. Well, remember the t value is our x value, which is the number of days. So after 5 days, we're going to find the population that is infected. So after 5 days, then 53.956 people will be infected. Now, when you are expressing this to us, you cannot state it as a fact. Like, oh, after 5 days, then 53.956 people will be infected, because that's not a fact. That's not actually going to be true no matter what. It's a prediction by the model. So you either have to start each sentence with according to the model, right? You'd have to say according to the model, after 5 days, 53.956 people will be infected, or you have to say the model predicts that after 5 days, 53.956 people will be infected. Now notice here as well, you might be saying, well, you can't have 53.956 people, but we don't really care. It's a prediction. It's not exact. So please continue to round to 3 decimal places, because that is what we've asked you to do this year in Precalculus. All right, letter B. Are there any horizontal asymptotes for f of t? If so, what do they mean? So when you graph it, like down here on part C, this is, if you graphed it on your calculator, this is what you should see. A graph that looks like this. So what's going to happen though is you're not going to know what maybe to make your y value equal to. So your y value is that maximum population, which is 4,500. So this is what your y value is going to be. And that is, if that's your maximum population, then that has to be a horizontal asymptote, because you're not going to go beyond 4,500 people, because there aren't any more people in the community. So that's a horizontal asymptote at your top end. That's going to be y equals 4,500. So the maximum number of students that could be infected according to the model, right? It's according to the model that we've given to you guys in the problem. Now there is also another horizontal asymptote. It's down here at y equals 0. However, that only approaches it as x gets smaller, as it goes to negative infinity. And we don't have negative days. You're not going to have a -1 day or -2 day or -3 day. Therefore, this asymptote is not relevant. So you either do not write it on your paper at all, or if you do write it down, you have to say this is not relevant to this problem. Okay, but if you write it down and don't say this statement, then you're going to get point deducted. So I would say don't write it down, or state what it is and then tell us it's not relevant. And then finally it says, after how many days will SAS cancel classes? Well, remember at the beginning we said we would cancel classes if 40% of our population had gotten the disease. So you take 40% of the 4,500 students, and that's when 1,800 students have been affected. So you can either put that in algebraically and solve, or you can just solve graphically. Put in a y sub 2, a horizontal line of y equals 1800, see where their point of intersection is, right? Point of intersection, and then you would see that after approximately 10.008 days, 1,800 people would be infected, which means that's when we're going to cancel school. So is that definitely when it's going to happen? No, it's according to the model, or it's a prediction made based on the model. So you have to say the model predicts that school will close after 10.008 days. Once again, you need to have 3 decimal points, and you need to tell us that it's a prediction and not a for sure thing. So if you don't say it's a prediction, then you're telling us that it's factual, when in fact it's just a prediction, so you need to use that word. All right, that was super short and sweet. So if you were confused by something, you need to come see one of us pre-calc teachers. Again, I hope you had a great IAS this weekend, and I'm out. Bye.